Hi there, curious minds. In this session we will delve deeper into the subject of chemistry, and the topic of atomic structure. Let's get learning. Let's start at the very beginning. What is an atom, you might wonder? Simply put, atoms are the basic building blocks of matter, the smallest particles of an element that retain all the chemical properties of that element. They are composed of three subatomic particles: protons, neutrons, electrons. Protons and neutrons are virtually identical in mass but differ in their charge. Protons carry a positive charge while neutrons have no charge at all. Together, they reside in the heart of an atom, an area we call the nucleus. On the other hand, electrons are much lighter and possess a negative charge. They don't stay in the nucleus, instead, they move rapidly in spaces surrounding the nucleus, the so-called electron shells, or energy levels. You might be wondering what distinguishes one element from another. This is where atomic numbers and mass numbers come into play. An element's atomic number gives its total number of protons. Hydrogen, for example, has an atomic number of 1 because it has just one proton, whereas helium has 2. The mass number, on the other hand, represents the total number of protons and neutrons in the nucleus of an atom. It's important to remember that electrons aren't included in the mass number, primarily due to their tiny mass compared to protons and neutrons. Electrons in an atom don't just randomly scatter around the nucleus. They fill up the shells in a very specific order, following the rules of quantum mechanics, striving to reach the lowest energy state possible. The innermost shell is filled first, followed by the next shell out, and so on. This explains why the periodic table is structured the way it is, with periods indicating the number of electron shells and groups revealing how many electrons are in the outermost shell. Our understanding of the atomic structure hasn't always been this sophisticated. Over centuries, it has evolved drastically due to numerous scientific discoveries and advancements. From the early Greek concept of indivisible particles to Dalton's atomic theory, to Rutherford's nuclear model, and finally to our current quantum mechanical model, our perception of the atom has transformed time and again. These groundbreaking discoveries have not only shed light on the intrinsic properties of atoms but also catalyzed further advancements in chemistry and related fields, proving that our quest for knowledge is an ongoing journey, continuously shaped by new findings and understandings. That wraps up our session. Remember, each day brings new learning opportunities. Until next time, stay curious.